In this video, I'm going to talk about TPU, or thermoplastic urethane, which is a very common 3D printed material that builders love to use in their combat robots. The reason for this is because it has an incredibly high impact resistance due to the fact that it bends and deforms rather than shatter and break. In this video, I'm going to talk about how you can use it in your designs and also some tips on how to 3D print it. While in some cases you can make your entire robot out of TPU if you really want, especially in these smaller weight classes, that might not always be advised, especially as you get higher up in the weight classes, because you're going to want to use other materials, much more rigid materials for certain parts of your robot, parts that either need to stay aligned in some sort of way, or if they end up flexing and moving, because this is a pretty thick piece of TPU. It's a pretty high infill, and this still bends pretty easily. So if there's parts you say that you don't want moving, then you want to use much more rigid material. That's why you'll see a lot of robots have their whole body kind of made out of TPU, but then have a carbon fiber top plate, or even sometimes a carbon fiber bottom plate to kind of keep it more rigid, kind of like it ends up essentially being a TPU sandwich with like rigid material holding it together. When designing parts that are going to be 3D printed out of TPU, especially if you're using the cheaper filaments, I'd try to avoid using support material and having overhangs, especially big overhangs, because if there's an overhang at the edge, it might end up curling up as it cools, and sometimes support material can be difficult to get off, especially compared to other materials. Although if you have, like, I know Ninja Flex can handle overhangs that a lot better than some of the cheaper filaments. It's just a thing to keep in mind when designing the part. Another thing to keep in mind is basically when fastening TPU parts together, if you have like a nut or the head of a screw, basically on the TPU part, if the TPU part is too thin, you can end up getting in situations where if you either tighten it too much, or if you get hit just right, that the head of the screw or the nut basically gets pulled through that hole, and then your robot is no longer together. And the best way to mitigate that is to either have a thicker feature between the head of the screw and the next part, or to try to have like maybe a washer to basically make the head of the screw bigger so that it's less likely to get pulled through. That's actually a big reason why on Hodag I actually used plastite screws, basically digging directly into the TPU instead of having to use nuts that could get pulled through. Next, we'll move on to the slicer. I typically use Overture TPU as my TPU of choice, and I print on a Prusa Mini and a Prusa Mark III. So that's what I'm going to be using for this demonstration. This might look a little bit different if you're using a different slicer. Obviously, the temperature and for the nozzle and bed is going to depend on the filament you're using. I like to keep the extrusion multiplier at 1. If I go too high, I've found that sometimes if I go too high, I end up with feeding issues. Also, with the nozzle temperature, it's worth noting that obviously, like, do it based on your filament used, but if you end up having feeding issues, sometimes increasing the nozzle temperature can help it flow properly and feed properly. For cooling, I'd either have I have auto cooling on, but some filaments you may want to always have the fan on. But basically, you need to have cooling in order for it to cool properly. My go-to fill pattern is gyroid, since it kind of supports everything in every direction and has a much more sort of uniform support in 3 dimensions. Although sometimes I may use the hex pattern. I know there's this technique that I believe Knuckle Sandwich uses, where it doesn't have any top or bottom layers, and it just has a hex pattern in the for the infill, and basically it's able to, when it gets hits on the side, it's able to have a much more uniform absorption of the impacts. This also so it makes it a lot easier for you to be able to also control how squishy that part is. The fill density, even if you aren't using this technique, the fill density and number of layers can really affect how squishy your part is without trying to use a whole different filament with a different shore hardness. You can actually just change how squishy your part is with fill density and like number of layers. These are my speed settings for using Overture TPU, not their high-speed TPU. Obviously, you'll end up bumping these numbers up a little bit faster if you're using high-speed TPU, and this definitely can vary based on manufacturer. I keep it maxed out at 40 millimeters per second and drop it a little bit slower for bridges and stuff like that. Now onto layers and perimeters. The most important setting here is going to be avoid crossing perimeters. This prevents all the stringiness and can prevent a lot of the zits that happen. So always have this checked. This seems to be a thing that myself included always has to learn the hard way. But if you forget everything else about this video, just remember this. Well, also the next part where I talk about fixing the issue that I guarantee you're going to have, but let's not get ahead of myself. And then the reason why I have the layer height the way it is that this is the lowest I would go, 0.1 millimeters. I just end up having a lot of detailed and complex parts, so I like to have the layer height at 0.1. I would go up higher if you don't have any like details in the Z-axis, but that's kind of up to you. The reason the horizontal layers, why there's a bunch of bottom layers and not very many top layers, I don't remember even what I was doing here, but typically how I design my parts and how I print them is that the part that is going to be on the outside, i.e. the part that my opponent's going to be hitting, is going to be the bottom layer of that part. And so that way I can make the bottom part of the robot, quote unquote, be really thick, and that way they're hitting the thickest part of TPU. That way I don't have to mess with a bunch of different like modifiers in the slicer and have some weirdness. I just change the number of bottom layers, and that's going to be the thickest part of the part. Also, it mitigates them hitting into layer lines and mitigates failures along layer lines. That's another thing to keep in mind when designing any 3D printed part for a combat robot, is the layer lines is probably going to be your most likely point of failure. Now let's move from the slicer to the printer. TPU is very hydroscopic, so you're going to want to make sure that it is properly stored and dry when you get it. A lot of things these days, like, they don't necessarily come dry straight from the factory, or at least as dry as they need to be. So make sure if you either have some impromptu way of drying it, I'm sure you can find other ways, but if you use a filament dryer, like one bought specifically for drying filament, that's what I use. Use desiccant packets. The heat and fans is great, but the desiccant packets is going to actually get the moisture out of there better than the heat and the fans do on their own. Also, if you're using a filament dryer and printing from the filament dryer, make sure it's turned off, because if you're heating up the filament as you're printing it, it's going to make it a lot more soft, and it's going to deform in the gears, and you're going to have feeding issues. As far as the build plate, I use a textured build plate, and I'm pretty sure that's recommended across the board. What isn't universal across the board is whether to use a glue stick or not, because I know Ninja Flex will absolutely destroy your build plate. So use a glue stick if you don't know, but I also Overture filament, it's fine if you don't use a glue stick, but if you don't know, just use a glue stick. Otherwise, use the manufacturing details. Honestly, for everything I say here, check the manufacturing. If they have a technical data sheet or if they have filament recommendations, always do that first before asking some guy on the internet. Before I move on to post-processing, I want to talk about the issue that I run into the most, and that you watching probably either had this problem in the past, are currently having this problem, are trying to fix, or you're going to have this problem in the future because you're trying to print with TPU, and that is failure to extrude or extrusion issues. Basically, your printer's going just fine, then all of a sudden filament just stops coming out of the nozzle. This is extrusion issues. If you have a Prusa Mini, and I've had this problem before where the filament just coming out the top, you're like, what the hell? Here's how to fix it. Obviously, the first thing you want to do is unload the filament, cut whatever's deformed, and then reload the filament. But in order to prevent it from happening again, there's a few things you can do. Make sure your filament dryer's off, because like I mentioned before, it can soften it and that can cause it to deform. Also, if you're printing inside of an enclosure, you may want to open up the enclosure or something like that, because the heat can get trapped in there, and that can also cause the TPU to deform. Additionally, if you're using glue sticks, like I mentioned before, for the print bed, if you don't clean that up enough times, obviously, I will admit, I don't clean the glue off each time, but if you let it pile up after too many prints, then you might have issues. So just cleaning off the print bed, you're gonna know when you printed too many times with glue. Like, that's what I mean by cleaning it. If you're not using glue, ignore that step. Another thing is increasing the nozzle temperature. This can help the filament flow better. Like, basically it's trying to extrude it faster than the nozzle can pump it out because it's not hot enough. But also you can decrease the extrusion multiplier to 1 if you have the extrusion multiplier higher than 1. And lastly, which is probably actually the most obvious and what most people say, is just slow down the print speed. Everyone says print TPU slowly, and this is why. It's because if you don't print it slowly, you'll have extrusion issues. So obviously, last thing to try, because I say last thing because it's the thing that you have to go back to the slicer to do, and that is lower the print speed. Well, also you can. That's not true. Most printers, you can lower the print speed on the printer, but yeah, lowering the print speed is another thing to try. Probably the last one, because you don't want your print to take longer, but yeah, print speed, lower that. The last thing I'll talk about is post-processing. Obviously you can still use side cutters to get rid of, support material and stuff like that. But if you don't have a perfect surface finish, you can't exactly use a file or sandpaper in order to smooth it out. So the only way that I've found, or the best way that I've found, is to use a soldering iron to essentially melt the top of it and sort of smooth it out. This can be it's real easy way to get rid of all the zits on there, and can make some bad surface finishes, especially if you're using a cheaper TPU, and kind of salvage a part that you might otherwise have to throw away to something that's at least usable. If you use a soldering iron to smooth out your TPU, make sure you do it in a well ventilated area, or have a fume grabber or whatever, a fume extractor, that's what they're called. And also, don't use either the same soldering iron or the same tip that you use for actually soldering, because whenever I've used a soldering tip for the same soldering tip for to smooth out a bunch of parts and then try to solder with it, it doesn't quite work the same. I think it creates a film on it or something. Just try to use a different tip for soldering as you do for smoothing out TPU. That's all I have for you guys today on TPU. I know Maker's Muse also did a video on combat robots and TPU, and I didn't mention some of the things he mentions because I didn't really get the chance to try them, so I didn't want to tell you guys about something that I didn't try myself. And also, it's pretty clear from his video, he's talking about using a lot of more high-speed TPU, while I don't use high-speed TPU. And so it's a little bit different approach. With that said, check his video out if you still want more information on TPU. But if you want a different combat robot guide from me, that should be on screen now. And I think you are super cool if you end up clicking that link. Thank you, and I thank you personally.